This morning you woke up in the middle of something. You were somewhere else. You were someone else, maybe. There was a place, a person, a feeling so specific, it had texture to it. And then you opened your eyes, and it was gone. Not faded, not blurry, gone. Like someone reached into your head and pulled the plug before the recording could save. You probably blamed yourself. Bad memory. Didn't write it down fast enough. Should have grabbed your phone the second you woke up. But here's what nobody tells you. It wouldn't have mattered. By the time your hand found the phone, the dream was already being erased. Actively, deliberately, by a brain that was working exactly as designed. Your brain does not forget your dreams. It deletes them. And once you understand why, you will never look at the moment between sleeping and waking the same way again. Ursula Voss spent over a decade studying the sleeping brain at the University of Frankfurt. Not sleep disorders, not insomnia. The specific electrochemical state the brain enters during dreaming, and what happens to that state the instant consciousness returns. She wasn't trying to explain why dreams are hard to remember. She was trying to explain why they disappear at all, when other memories from the same night, procedural things, emotional impressions, physical sensations, survive just fine. What she found was not a storage problem, it was a chemistry problem, and it starts before you even open your eyes. During REM sleep, the phase where almost all vivid dreaming occurs, your brain operates on a completely different chemical substrate than it does when you're awake. The neurotransmitters that govern conscious memory formation, norepinephrine and serotonin, are almost completely suppressed during REM, not reduced. Suppressed. Your brain deliberately dials them down towards zero. This is not an accident. This is a feature. Norepinephrine is one of the primary chemicals your brain uses to flag an experience as real, to stamp it as something that actually happened to you, something worth encoding into long-term memory. Without it, the hippocampus, the structure that acts as your brain's memory consolidation center, cannot do its job. It cannot transfer what you're experiencing into permanent storage. So whatever happens inside a dream stays inside the dream, floating in short-term neural activation with no pathway out. Then your alarm goes off, or the light comes through the curtain, or your body simply decides it's done sleeping. And in the first few seconds of waking, your brain does something that feels like nothing. It transitions. Norepinephrine surges back. Serotonin returns. Consciousness reassembles. You become, in the neurological sense of the word, yourself again, and that surge is the exact moment the dream dies. Matthew Walker, a sleep scientist at the University of California, Berkeley, who spent years building the most comprehensive map of human sleep stages ever assembled, describes this transition in precise terms. The chemical environment that allowed the dream to exist, the low norepinephrine state, the offline hippocampus, vanishes the instant waking neurochemistry floods back in. And because the dream was never encoded in waking chemistry to begin with, the new chemistry cannot read it. It is like printing a document in one software and trying to open it in another that does not recognize the file format. The file exists. The program just cannot see it. You have approximately 90 seconds. That is the window researchers have identified in dream recall studies. Within 90 seconds of waking, most people lose more than half the content of whatever dream they were having. Within 5 minutes, that number climbs past 70%. By the time you have made coffee and checked your phone, the dream is not fading anymore. It is already gone. What you remember at that point, if anything, is a fragment of a fragment. A color. A name. A feeling with no image attached to it. Antonio Zadra at the University of Montreal ran one of the longest continuous dream journal studies ever completed. Participants tracked their dreams every morning for weeks. The data showed something nobody had fully expected. People who woke during REM sleep, as opposed to after it, remembered their dreams in significantly more detail, not because they had better memory, because the chemical transition had not started yet. They woke up while the dream was still alive, while their brain was still running in the neurochemistry that produced it. The moment that chemistry changes, the dream becomes unreadable. Now, here is where most people stop. They hear norepinephrine suppression and hippocampus offline, and they conclude the brain is just poorly designed for this. Dreams are data that slips through the cracks. A quirk? An evolutionary oversight that we have not corrected yet. That reading is wrong. And Voss was one of the first researchers to articulate exactly why. Think about what would happen if your brain did encode every dream as a real memory, not as a dream, not as a thing that felt like it happened, but as something that actually occurred. You sat at a table with your dead grandmother. You flew over a city you have never seen. You failed a test in a school you have not attended in 20 years. You committed acts of violence. You were the victim of them. If your hippocampus stamped all of that as real, with the same chemical authority it uses to mark genuine lived experience, you would wake up every morning unable to separate what you did from what you dreamed. Every morning, the line between your actual history and the hallucinated theater your sleeping brain staged would be a little more blurred. Your brain does not delete dreams because it is bad at storing them. It deletes dreams because storing them accurately would make you unable to trust your own memory of reality. The chemical architecture of REM sleep, the deliberate suppression of the very neurotransmitters that create permanent memory, is not a flaw in the system. It is the system. It is your brain maintaining the single most important boundary in human cognition, the line between what happened and what was generated. Every morning, without your awareness, your brain runs this calculation and chooses erasure, not because the dream was not vivid, not because it was not emotionally real, but because filing it as a real memory would corrupt the archive. There is a term for what happens when this system breaks down, when the brain begins encoding dream content as real experience, when the boundary between memory and hallucination starts to dissolve. It appears in the early stages of certain psychotic disorders, in the prodromal phase before symptoms become obvious. Patients report a strange certainty about things that did not happen, not confusion, certainty. The kind of certainty that only comes from a memory that was stamped real. Your brain runs a continuous operation every single night to prevent that from becoming your baseline state. And it does it by building the neurochemistry of dreaming so that memory formation is structurally impossible while it is happening. This also explains something that has puzzled researchers for decades: why some people remember their dreams consistently and others almost never do. It is not a talent. It is timing. People who remember dreams more often tend to wake more frequently during the night, often briefly, during or just after REM cycles, before the chemical transition is complete. Their recall window is longer, not because their memory is better, but because they are catching the dream before the delete command fires. People who sleep deeply through the night, passing cleanly through REM and into later sleep stages, rarely catch that window. By the time they wake in the morning, multiple full dream sequences have already been erased. The dream journal advice: keep a notebook by your bed. Write the second you open your eyes. Do not move. Do not check your phone. Is not self-help mysticism. It is neurochemistry. Every second you wait after waking is a second in which norepinephrine is rising and the content of the dream is becoming chemically inaccessible. The notebook is not there to help you remember. It is there to capture what is already leaving. Zadra's research also found something quietly unsettling in the data. People who recalled more dreams did not just report more content, they reported more emotional intensity in their waking lives on the days following high recall nights. Not more anxiety exactly, more vividness. As if catching a dream before it disappeared carried some residue of the state it came from into waking consciousness. The researchers did not know what to make of that. They still do not, entirely. But it suggests that the deletion is not just protective, it might also be a kind of emotional regulation. The REM state processes emotionally charged experiences, strips the charge from the memory of them, files the pattern without the intensity. If you catch the dream before it is processed, you might be catching it mid-edit, before the disturbing content has been diffused, which means the dream you remember most vividly might be the one your brain was not done working on yet. There is one more piece worth knowing. The state-dependent memory theory, developed by researchers studying why memories formed in one neurochemical state are hard to access in another, offers a final part of the picture. Memory is not just stored by content, it is stored in context. Memories encoded under high stress are easiest to access when you are stressed again. Memories formed in the low norepinephrine hippocampus offline state of REM sleep are encoded, to whatever extent they are encoded at all, in a neurochemical context that ceases to exist the moment you wake up. Even if the brain tried to store the dream, you might not be able to retrieve it in the waking state, because the key that unlocks it, the specific chemistry that was present when it formed, is gone. You would have to go back to sleep to remember, and by then you would be dreaming something new. This morning, you woke up in the middle of something, and your brain made a decision so fast and so quiet that you never had a chance to argue with it. It looked at the vivid, emotionally saturated, completely convincing experience you just had, and it chose not to file it. Not because it was not real enough, because it was too real. Because a brain that cannot erase what it dreams is a brain that eventually cannot tell the difference between the life it lived and the one it invented in the dark. The forgetting is not failure. The forgetting is the protection. And every morning when you chase the last fragment of a dream down a corridor you cannot quite see, you are not failing to remember something. You are surviving something your brain already decided you did not need to carry.